physics class. This is Mr. Mellinger. So I'm going to do a solution video for the day 40 assignment on gravitational potential energy. And in fact, I'm not going to do very much here. You can answer questions 1 through 5. They're straight off of the slides off the previous video. And I'm going to do part of this table for you. It's just like the one that you saw on the slides. I'm going to change it up a little bit though. So let's read the question. A ball with a mass of 2 kilograms is dropped 4 meters, and it's done on the moon. So the gravitational acceleration on the moon is not 10 meters per second squared like it is here on Earth. It's about 2 meters per second squared. In fact, it's a little bit less than that, but we'll just keep the number simple and make it 2. All right, so we're going to fill in this table of potential energy, kinetic energy, and total energy. Okay, so when the ball is 4 meters off the ground, then there's the formula right there. So the mass gives us the mass of 2 kilograms. The gravitational acceleration is this number right here. It's 2 meters per second squared. And the height it gives us is 4. So 2 times 2 times 4 is going to equal 16. And the unit of measure for any kind of energy is a joule, J. All right. Now we're going to go down. I'm going to do a couple more here. I'm going to do actually one more here. Now, at 3 meters, well, the mass is still the same. It didn't change. It's still 2 kilograms. The gravitational acceleration is still 2 meters per second squared. So 2 times 2. Now the thing that changed is the height. The height is now 3 meters times 3. So 2 times 2 times 3 equals 12 joules. So it now has 12 joules of potential energy. All right, I'm going to leave it for you to solve the rest of them exactly that same way. Again, the 2 and the 2 are going to stay the same all the way down. The only thing that's going to change is the height. Now the kinetic energy. While you're holding the ball, it has no kinetic energy because it's not moving. Kinetic energy is the energy of motion. So without even doing a calculation, you can simply write 0 joules. Okay? 0 joules. Now the total energy is simply adding these two numbers together. So the total energy over here is Ke plus Pe, so it's, or Pe plus Ke, either way. So it's 16 plus 0 equals 16 joules. So it has 16 joules of total energy. And the law of conservation of energy says that this number, once that energy is in the ball, once it falls, the total energy stays the same all the way until it hits the ground. And then the energy is released from the ball. So we can go ahead and write 16 joules all the way down. And again, this at the bottom, 0 means just before it hits the ground, because once it hits the ground, as I said, it releases this energy. Okay, so now we know that Pe plus Ke equals total energy. So right here we have 12 plus some unknown number equals 16. So you can do that as a subtraction. 16 minus 12 equals, and I'll go ahead and write that. So 16 joules, which you got from over here, minus 12 joules, which you got from right there, is going to equal 4 joules. So it has 4 joules of kinetic energy. So at 3 meters, there's the potential energy, there's the kinetic energy, and there's the total energy. And I'll circle these as well. All right, so you go ahead and fill in these 3, again, using the same formula right there. And then once you have these numbers here, you can take this number, subtract this number to get that number. So I'll leave the rest of those for you to do. Okay, have a good day.